Hi everyone. Hi, good evening to all. Can somebody respond that am I audible? Is everything all good? Hmm. Am I audible? Hello. Yeah, thank you so much. Okay, guys, so we'll wait for like 2-3 minutes and then we'll move ahead with the things. Okay, so meanwhile, happy Raksha Bandhan to all. Uh, I, so I guess you're all doing good, isn't it? So we'll wait for just couple of minutes and then we'll start. Mean there is no issue if you attended it late or anything. At the end of the workshop, you'll be sharing some of the questions that you need to complete and submit. So that will be important if you want the certifications and the rest of the thing. Okay. So that is the thing. Okay. Good evening to all. How are you all doing? Just you can ping like you're doing good, great, and whatsoever. You can ping that in the group, in the chat. And we'll start in just couple of minutes. Since today and tomorrow we have Raksha Bandhan on the same day, I have to travel today, so I might bind up the session 10 minutes early. Okay, so today's session will be around 45 to 50 minutes. Okay. Hmm. Okay, just hang on for just couple of minutes and then we'll start. Just couple of more minutes. Let us wait for a few more people to join in and then we'll begin with it. Hmm. Okay. Mhm. Okay, so just minimize the things. Just hang on for a couple of more minutes and we'll start then. Just one more minute and we'll good to go. Meanwhile let us revise the things that we covered yesterday. Okay. Hmm. So what we did yesterday was, there is no need to download the Java documentation. I just saw the question in the chat. It is available online. Just Google it, Google that Java documentation. You will find it online. So there is no need to download the Java documentation. You can refer it online. Actually, there is no need. There is no requirement you should download the Java documentation. You can refer it online. Just Google Java documentation, whatever version of Java you are using, 8, 11, 17, or whatsoever you are using, you can go for it. So meanwhile, let us start the class. In just 2 minutes, we'll revise the things that we covered yesterday. So yesterday we studied about what is Java, what are the career objectives of the Java, and what were some of the language features, and we started with the identifier and the rules to define the identifier. Quickly I will, and we studied also about the three editions of the Java. What is standard edition, what is the enterprise edition, what is a micro edition, and we studied about all these things. And we also just had a glimpse about what are the language features. Meanwhile, during the course you will learn about uh, how these features are actually implemented in Java and how beneficial it is. So we started with the rules of the, we studied about what is identifier and some of the rules, and we also solved one of the question on this. And then we moved on to the reserved keywords. So we studied about that there are 53 keywords in Java, out of which uh, two are obsolete. We don't use it. That is go to and cons. So today, basically, we will be talking more about this keyword. This is called as data types in Java. and we will talking about typecasting in Java. Okay, how do we cast one variable to another? So this is our agenda for the today. So our agenda for today is to basically study about what's wrong with this. Let me take this one. Okay. So today's objective is today we'll learn about data types and typecasting. So these are the two topics that we are going to cover today. Okay. So so if you remember the example from the last class, the nomenclature one, right? You remember the nomenclature, like this is me, Ashok. I have some qualifications. I have some family background, correct? Family background, some qualifications, and rest of the things associated with me. And how do we address this? Using a name. And what is my name? That is Ashok, correct? And this Ashok represents an identity in the social life where he had some background, some family background. He had some set of physical characteristics. All these things are distinguished by this identifier, my name. Similarly, okay, so let us go back to the question then, how this Ashok is decided that my name should be Ashok. Since I'm a male child, so my name is Ashok. If I have been born as a female, so my name might have been Anisha or something else. Okay. So we have to define this primarily. Okay. So in Java, what happens is, if you remember, identifier is actually the name. Okay. And this identifier points at something. So it could be a number, it could be a character, it could be a Boolean number like true or false, or it could be a number like 5, 6, 7, or it could be a huge number like the distance between Earth and Sun, or it could be your mobile number. So all these things, like these all are of different types. So these all are called as data types in Java. If you see here, there are bunch of 8 data types that are available in Java. So let us study about each one of them in a bit of detail. So basically, what is the data type? So data type is basically a classification that shows what type of variable are we going to store in it. Means what type of value it is going to store. Correct. So if you see here the names of the data type, it is very evident from the name. Byte is a byte if you are all IT graduates, right? Or pursuing someone we might in software or you know byte. Byte is the smallest. After bit we have byte that stores something. It is very clear that byte stores some small value. Then we have short. Then we have int. Then long. So these all, if you see, these are different classifications of different types of data that we can store. Okay. So let us go down. So in Java, so basically data type defines what sort of thing are we going to collect in it, right? What sort of thing it is. And on basis of that, we define the type of mathematical and logical operation that can be applied to it. For example, I'll show you. Let us say, let me raise the screen. Let us say I want to calculate some expenses, correct? I want to calculate some expenses. So expenses could be what? Let us say there could be your college fees, correct? So this college fees will be number, correct? It will be a number, a decimal number, like you pay 2,000, 20,000, right? So this cannot be a string, isn't it? So if we let us say I want to calculate your expense, this is your college fees, and then you have some examination fees. So this is around like 500. So if you see these these two data type can be added, isn't it? So it will make sense. But if you try to add, let us say you are in a second year or not. So this value can either be true or false, like is second year student, second year student, and this is true. So can you add these two numbers? And can you add these two? No, it is not going to make any sense. So that is why it is really important that we already classify what sort of data this variable is going to point at. And on basis of that, we decide the operations that we are going to perform on it. So if you see the definition here, that is very clearly written. A data type in programming language is classification that specifies which type of a value a variable has and what type of mathematical relations are we going to apply on it. isn't it? So that is why data type is important. And the second thing that is written here is that every assignment in Java is already checked by the compiler for the type compatibility. That is why it is called as strongly typed language. I will justify this more. It is a very common interview question that people will ask you, like, how can you say that Java is a strongly typed language? And you have to justify that thing. So I'll give you an example. So let me go to my Eclipse again. Okay. And what I want to do is, let us say, what I want to do is I want to store my mobile number. Okay. What I want to do is I want to store my mobile number. Correct. So what we'll do is first we'll write a identifier. A identifier is what? It will point to some value. Okay. Something. So I'll write here is like my mobile number. Okay. And this is equal to 70912683 and 25. Okay. So this is my mobile number. If you see here, so this actually this is my identifier that is pointing at this particular value. Correct. So but it is throwing an exception here, like cannot be resolved to a variable. What other thing is we need to specify that this identifier is going to contain this value. Okay. So what is the type of this value that we are going to store? Okay, whether it is going to be a Boolean, like true or false sort of thing, or a character, or a string, or a double, or what it is. So we need to define before assigning any value to here. So I have to define it as long. Then see, it works perfectly fine. Okay. So I have to put a L here to make define it. This is a long. We don't worry about it. But see, so before declaring this identifier, we need to provide this data type, like what sort of value it is going to store. Okay. So the syntax for defining to storing any value in an identifier is that first you have to write the data type, then the variable name. Okay. And then we assign the value here. Remember. So that is why Java is a strongly typed language. Since if you want to store anything in this particular identifier, you need to define the type of value that is it is going to store previously. You cannot directly store any value in this identifier without specifying the data type that you are going to the type of data you are going to store. That is why it is a strongly typed language. Like at the compile time, it is going to check like what sort of data you have stored here. So you have to declare it previously. Otherwise, cannot like assign this value to this. It will throw an exception, cannot resolve type. So remember, why Java? I will again repeat the thing. Why Java is called a strongly typed language? Because if you want to store anything in this particular identifier, you need to specify the type of data that you are going to store in this identifier. Correct. So did you get that? What I'm trying to say? So can someone ping thumbs up in the group so that I can understand that you have correctly understood this thing? Just a thumbs up sort of thing, the approval that you got what is strongly typed language, and why do we need to study this data type, and we need to why do we need to declare it previously? Just a thumbs up. Okay, cool. Thank you. So, so I'll again repeat the concept and then I'll go ahead. Why Java is called a strongly typed language? Because if you want to store anything in this particular identifier or any variable that you're going to declare, you need to specify the type of value that you are going to store. Okay. So I'll give another example here. Let us say I want to store some characters. Okay. So for character, what I need to do? First, I need to put this char, and then like I have to put like my char, like my char variable, and now I can store a value a in it. Okay. So this is the thing. But if I try to put some other value here, let us say I'm just trying to put let us say 2.3f. See, it is so what if you see there is a warning here stating add cast to char. Why? Because the type that you have specified here is a character, and that the value that you are going to put here is a float value. So there is a type mismatching. We'll cover these things in great detail in the today only, but here just I want to show you that why Java is strongly typed. Okay, so let us go back to the notes section and let us learn about the data types. What are data types in Java? Okay, so let me go back to the notes. So whatever the 8 data types that you see here are all predefined in Java. These are all called as primitive data types. So these are all primitive data types. Okay. So let us see the classification of this primitive data type for numeric values, right? So what could be the numeric value? Either it could be a whole number, isn't it? A whole number, or a floating point number like 2.3, 6.8, or a very high precision number. So if you see the classification, the first one here is a numeric data type. So in what could be numeral data type? Either it could be a whole number or a decimal number. So for decimal number, we have something called as float and double. So we'll see the difference between two. And for storing the integer number, the whole numbers, we have these four: byte, short, int, and long. We'll see like what are their capacities, what range of value they are going to cover in the great detail in today only. But let us see the classification now. For characters, like the what are characters, like the alphabets, the lowercase, the uppercase, and some of the special case characters. So these all come under char data type. So we have char data type to store all these characters, and ultimately the Boolean one. If you have to store some logical thing like true or a false, correct. So we can use like true and false. So we are going to use this Boolean data type for it. So this is just a this is just a classification of the primitive data types that we have in Java. So we have numeric, we have character, we have Boolean. In numeric, we have again a classification for the integral, and we have again for the for the whole number and for the decimal number, and we have the bifurcations below. Okay, now let us learn in depth about the data types and when we should use which sort of data type. Okay, what is their capacity and rest of the things. So to begin with, we'll start with byte. You know that the bit is the smallest unit in which we store. The bit is the smallest unit of memory that we use, correct? So basically the first one we have something called as byte. So basically I'll tell you the use of byte. So so whenever we have to transfer something, anything over the internet, okay, so everything goes in a byte stream. There's something called as stream. So you have to read any file. So you read it as a file input stream. So maybe we might have some workshop further where we might cover this file input output stream. So as of now, just I will give you an example where they are used. So if you have to send anything over the internet, anything that is broadcasted over the internet, or any send, these all data travel into packets of stream bytes. So there this byte data set is used. Okay. And then if you have to read anything from the files, then the file that is passed to you come in format of bytes, where it is divided into chunks, small chunks that can be traveled across the things. Okay. So the maximum and the minimum value that you can store is, maximum value is +127, and the minimum value that you can store is -128. So if you want to calculate the range, like if you see that there are like eight buckets, isn't it? This is 0, 1, 2, 3, 4, 5, 6, and 7. So these are 8 buckets, and the first one is for the sign. I guess if you are into if you are into college, you might be studying about the first bit is reserved for storing the sign, and this is the capacity for rest of the thing. So so the maximum limit is 2 to the power 7 minus 1, and 2 to the power, no, what is it? 2 to the power 7 minus 1, and 2 to the power 8, and 2 to the power 7, 2 to the power 7 minus 2 to the power 7 minus 1, and 2 to the power 7 minus 1. So this is the entire range that you are going to cover using this byte. If you use any byte, So this is the minimum and the maximum thing that you are going to cover. Okay. So this was about byte. We'll see the limits things very soon when I get into my editor thing. First, let us study about the use. Okay, so so the size of this byte is 8 bits. Okay, so the next one is short. So it's not very it's very uncommon that you find short now in use. It was in great use when we had 16-bit machines, but it is there. It's not now particularly very much used, but the data type is there. So here what happens is the size is 2 byte and the maximum values again you can calculate using the above formula that I showed you, 2 to the power 15 and 2 to the minus 2 to the power 15 plus minus 1 in the vice versa conditions, and you can get the range. So this was about the byte data type. This was about the short data type. Now this one, the integer, this is really important because you are going to use it a lot. Like this is a very common data type. If you store a number, a whole number, this will be the most common data type that you are going to use. Okay, so the size is basically 4 bits. If you 4 bytes, if you convert into bits, it becomes 32 bit. So again you can calculate the size as 2 minus 2 to the power minus 2 to the power 31 minus 1 for the lower limit, and 2 to the power 31 minus 1 for the maximum limit. So this is the maximum number valued that you can store in a variable if you declare it as int. Okay, so this is the most used data type to store a whole number in Java programming language. Okay, so if let us move to the next data type, and we'll see the example for all these data type. Don't worry about it. So if we move ahead, the next data type is your long. So long, if something exceeds the limit. For example, if you see how many numbers digits are there, 3, 6, and 4, 10, correct? So this is a 10-digit number. Now let us imagine what is your number. Let us say we have some number like 7091268335. Okay, if you see this number, so if you try to store it into an integer, this is not going to get stored. Why? Because the maximum limit is this, and this value is going to exceed this, isn't it? So what we do is, this, since this number exceeds the value of the maximum limit of integer, so we store all such data types in long. So long is another data type which is which stores your integral values, but it has got a wider range. Wider range means it has got the maximum capacity as you can see here, 2 to the power 63 minus 1 to the minus 2 to the power 61 plus 1. So this is the entire range, and this range is this is a very good, quite long range. So where you can store a very big integers, right? So this is pretty long enough. This had got a very good capacity to store long values, like which have greater range, greater than range other than this, which doesn't falls in this integer range. We store it into long. Okay. So now, since we have just a talk about the integral values, let us talk about the double values. Double values means let us talk about the decimal numbers. So there are basically, we have two types of data type to store decimal values. The first one is float and other one is double. So the basic difference between two is float is for if you want lower precision. Like, okay, so there is an open question. This is a task for you all. I'm assuming that you all are college grads, like you are all in college. So you have to figure out the difference between a single precision and double precision. Okay, so this is your task this is one of your homework. You have to figure out the difference between what is the difference between single precision and a double precision, and you have to post it in our community. I guess you have joined the community, everyone, Discord community, or I'll also post it as an assignment. You have to figure out what is the difference between a single precision and a double precision. Okay, and how these values are stored in a bitwise structure. So this is your task. You have to figure it out. I'm not going to tell you what's the difference between a single precision and double precision at the bitwise level. At the bitwise level, you have to figure it out. Okay. So, but first I will tell you the difference between these two. What happens is out of the we'll talk about the difference in the scope of storing this value. So float is basically used where we have very less precision. Like you have to measure something, you have to measure some values in which you need the decimal precision value up to 5 to 6 places. And if you want to store the very precise data in decimal format, where you need very high precision, like you have, then there is double that contains that have a precision up to 14 15 decimal places. Like let us say you want to store some value like 1 2 2 2 3 4 5 6. So this much precision you want. Let us say we are writing an application for a medical surgery, and where where we need a precision, very precise calculation. So in that case we'll use this double. Okay. So because there is a questions of somebody's life, like if we are writing any program for medicinal purpose, like what sort of drugs, the dose we are going to give it, or what sort of anesthesia, and it is a very we can say a very risky environment where there is a change of even a point minute changes, and it is going to create blunders. So in those cases we are going to use double, because it will be very precise and we can easily use that thing. And float is for where we require very less decimal precision. Okay, so this was the thing about float and double. Now let us go down, and the last two data types that are left with us today is Boolean and the char data type. Okay, so Boolean does not have any range, since we are going to store only true and false in it. So there's no question about the precision. And the next thing is characters, and this is a very good thing. Characters are really very peculiar and common thing that you'll use in your programming life. So in char data type, you store all the characters that is possible in the world. So Java basically supports a Unicode characters. Like if you see any characters in the entire digital world, like there are so many characters other than A to Z and capital A to Z. Like you remember all these ASCII values, like it starts from 96. You know, you work with the ASCII values. So the ASCII values are only limited to 256, correct? So there are other character schemes, something called as Unicode characters. So the entire digital character that you see in the world are basically encoded and in Unicode format. So Java supports all these characters. In these 2 bytes of data, you can print any character that is there in the digital world. Everything gets encoded in the form of Unicode. So if you search on the internet, you will find. Okay, I'll not get into much detail about it, but if you want detailed discussion, I'll show you. Just hang on. If you just search on the internet about Unicode in Java, okay, so you'll find some of the very good reasonable content, like how it is different and how we can print any character here. Just do a Google search, and you will find a lot of detail about it, like how Java can actually store all the digital characters that is possible in the world in the character using the Unicode. Okay, so this is your second task that you have to figure it out. Okay, so this was all about the type of data, all the data types. Now let us get our hands dirty and let us see some of the example, and then we'll move ahead. Okay, then before getting into this, let us talk about literals too, and then we'll get into our editor for some of the hands-on thing. So what are literals? So first let us talk about literals, a bit about it. So any variable, we used to write identifier. So these identifier, so using those identifier, we declare a variable in which we can store some value, right? So let us say I write x is equal to 10, and we define, since it's an integer value. So what I will do, I will write int here. Why? because this particular variable is pointing at a value that is of type integer. Okay, so any variable that is storing some constant value in it. Okay, any constant value. So what could be a constant value? So it could be numbers only, isn't it? So these all are called as literals. So any constant value which can be assigned to a variable is called as a literal. So any constant value you are seeing around yourself, like all the integers, doubles, hexadecimal, octal, and float, these all are literals. So all these values which can be assigned to any variable, any constant value, these all values which are assigned to this variable are called as literals. So Java supports binary, and we have also did, and we use in our daily life, that is a decimal system. There is a binary system. There is a hexadecimal system. There is an octal system. So these all are different type of literals. Okay, these all are constant values which can be assigned to any variable. Okay, so so I'll let us now discuss this also, and then we will see the rest of the thing. So if you remember the size from there, the top part. So what was its size? Its size was, what was its size? 8 bits. This was 16 bits. This was 32 bits. This was 64 bits. This was again 64, I guess. I don't remember the size. And this was also, I don't remember the size, but definitely it has got size greater than float. And this was also 8 bits. So if you see the size procession, so this is as in ascending order, smaller to greater. If you compare it size wise, byte has got the minimum size, then we have short, then we have got int, long, then float, and then double. Okay, so this is just a size wise thing that size wise you can see a horizontal table in which I am showing a diagram in which I'm comparing the size side by side. Okay, so I'll tell you why I have shown you this, because when we'll study about typecasting, this is going to help us out. So now let us see how to declare all those variables, and how do we all uh, declare all these variables and store some of the literals. Okay, so let us see the example of each one of them step by step. Okay, so first I will start with uh, what was the first one? Bytes. So I'll declare a variable called as byte. So I will let us name it as my var byte, and we'll try to assign some value. So if you remember my class from the beginning, the maximum value that we can assign to is 127, isn't it? So I'll show you. My byte value is, and then I'll try to print the particular variable, that is my var byte. And if I run it, see here, if you see the output here, it is my byte value is 127. Now what if I'll do is, if I try to put 1278 and if I run it, just observe the logs. See what exception do we get? Type mismatch. Exception in thread main, unresolved compilation problem. Type mismatch cannot convert from int to byte, right? And I'll tell you why it is doing. I'll tell you. The previous value was also by default. If you remember, previously we put 127 here, right? But if you remember, its range is less than that. Its value lies in the range of the byte. That is why by default implicitly 127 was automatically converted to byte. But since we now use some other value that was greater than 127, right? So what it could be? So it was an integer value, and what you declared here, you declare here as byte. And what we are trying to do, previously what we wrote here, 1278. And what we are trying to do is, we are trying to put this integer value into this byte, correct? So that is why it's throwing an exception here, that cannot convert from int to byte, because byte cannot never store this 1278. Why? The maximum range is minus 128 to 127. Okay. So this was the thing. That is why Java is a strongly typed language. You need to define what sort of value you're going to store in it. If you try to store something else, it is going to throw this sort of exception. Sometimes it won't. I will discuss all these things in typecasting. Okay, like when it is going to throw exception, when it is not. So this is how we declare byte, and this is the value that is stored. Okay, so let us go ahead. Now let us talk about short. So you have to declare any value as short. So what you will do is, first you will write the what? First we'll write the data type. If you see this one, data type, variable name, and the value. So if I want to store data type called as short, so I will write short here. That is my data type, and then we'll write mm, a variable name, my short var, and we'll try to assign some value like 128, 1238, and this can easily contain its value. Similarly, if you want to write something as int, and if I write as int my int var, and you can assign some value to it, 1212. Okay, so this will contain the integer value. Now I'll show you that particular example. If I input my mobile number here, 7091268335. So don't try to call it, it's not my number. Okay, so if you see here, what does it say? This is out of range. Let me print this value, and I'll show you the exception. My int var, and then I'll try to print this value. Okay, just focus on the output, what it says. Huh. Just see the output. What does it say? It says that the literal 7091268335 of type int is out of range. So if you remember the range, what was the maximum range? The maximum range was 2 to the power 64 minus 1. 2 to the power minus 2 to the power 64 minus 1. Correct. But this value 7091268335 is outside this range. So you cannot store this value in this my int var. Okay, because here you are trying to store an integer value, but what you are trying to store this value is out of that range. So to resolve this, one of the way is, what you do is just convert this int to long. Okay, but still it is throwing the I'll again run it and show you. Again it will throw an exception. So let me run it and I'll tell you why. See, it is still showing that type int is out of the range because the value that is putting here is integer. So to simply point it out that it is a long, you have to put this L at the last. So if you put this L at the last, it signifies that this is no more an integer. This is the somebody has correctly pointed out that for integer it is 2 to the power 32. Yeah, I'm sorry about that. Yeah, it's for long it is 2 to the power 64. For integer it is 2 to the power 32. Sorry, thank you. I was just mistaken about it. Okay, the integer range is actually 2 to the power 32. Thank you for pointing that out. 2 to the power 64 is the maximum range for the long, not for the integer. Thank you so much. I just spoke that, and apologize for that. Okay, so if you just put this L here, so what it will do is, this will point that this particular value is no more an integer. This is actually a long. Okay, so this is how we converted this particular integer into a long. So this is the way also to define a long value. Correct. So if I run it, now we will see that this code runs successfully. There will be no exception. See, my var is 7091268335. Okay, so this was the thing. Now let us quickly talk about float and double. So first I'll talk about double. So if I write here double and pi, if I write is equal to, what is the value of pi? 3.1427, something like that. I don't remember that. And if I try to print here um, value of pi is and we'll get this value, right? Correct. So I have got it here. So actually you can store it in float also. So first I will what I will do is now I will just convert it into float and let us see that what exception do I get, and then I'll teach you about why we are going getting that. So if I try to do it, so what exception do you get here on the screen? This what this the exception says that unresolved compilation problem and type mismatch cannot convert from double to float. What does that mean? This means that this pi is actually a float value. This is going to store a float value, and the number that you're supplying is a double. So by default, remember this is a rule of thumb. By default, any decimal number that you provide is double by default. Okay, so this is the rule of the thumb that you have to remember, that any decimal value that you write in Java programming language is by default double. Okay, so I'll write it here that any decimal number is by default double. So why did we get that error? Now you are clear. We have declared that the pi is going to store something that is a float value, and what we are providing? Double. So if you see the size of the float, you know that the size of the float, the capacity is less than that of double, isn't it? So you have already defined, and Java is a strongly typed language. So you have already defined this particular value, pi is going to store float, and you're going to give me double. So this is out of my capacity. So that is why there is a type mismatch. So so then what is the solution? How do we define float values? So if you remember, on the top we were putting L for the long. Similarly, if you put F here, so it signifies that this decimal number is a float number. If you put F here, which means that this particular decimal number is a float. Now if I run it, this code is going to compile very fine. See, the value of the pi is 3.1427. So what did we learn from here? The conclusion is that any decimal number that you declare in Java is by default double. If you want to convert into float, just put F at the back of that particular number. Okay, so I guess you got it. Can I get a thumbs up with the people? Um, uh, that people are listening to it. Can I get a thumbs up? Okay, thank you so much. So let's move next to the Boolean. Okay, so the next thing is Boolean. Okay, so I can declare Boolean as, let us say, is student, and I'll assign false to it. Okay, and okay, so and let me declare another variable as Boolean, and let us say is married. Is married, and I'll put is equal to true. Okay, so I'm still single, I'm not married, I'm still bachelor. So I just, that was a joke. Okay, so so these are the only two permissible values, that is false and true. So these are the only, unlike any other programming language, if you remember, right? In other programming language, we have a provision to assign like is student, is unlike any other programming language, we don't have provision to assign 0, 1 or any other value to be treated as true. Here, these are the only two permissible values for true and false. if you use 0 or 1 in this place, this is going to throw an exception. I'll show you that. So I'll just try to print SISO. Okay, and is Ashok married? And then I'll put here is married, and then I will try to put, okay, is Ashok student, and then let us see this is student, and let us just observe the logs. Now this code will work perfectly fine. Is Ashok married? True. Array, I'm not married, man. Okay, is Ashok a student? False. Okay, so this was the thing. But now let us try to put something here as 0 instead of false, and let me put 1 as 2. Unlike any other programming language, we are just trying to put 0 and 1 in case of true and false. And let us see the output. No, what do we get? Type mismatch cannot convert from int to Boolean. Observe the logs. Observe the console. What is it saying? Type mismatch. Why we are getting a type mismatch? Because where is my pointer? Okay, what here we are trying to do is this 0 is treated as integer and this 1 is also an integer, and what we are trying to do is we are trying to put this value integer into a Boolean. So in Java we cannot do that. 0 and 1 are always treated as integer. They cannot be assigned to Boolean. So remember, the rule of thumb is the only permissible values for Boolean is true and false. So true and false are the only permissible value for primitive for Boolean data types. Let it be like Boolean data type. Okay, so did you get it? Like, what is the permissible value for Boolean? You cannot use anything else other than true and false. So remember thing. Okay, so and the last data type is character. So for if you want to put something in char, let us say char, let me like char gender. So you can put here as M. Oh no, you have to put it in a single quotes. Okay, not gender, it's gender. So I can print it like what is the gender of Ashok? And I'll put it here as my gender. And if you run it, see here. Okay. Oh, sorry. This is because of this. So let me just comment it out. This. Okay. And then let me run this program. Okay. So see, my gender is male. So this is how you can store a character value. Okay. So this was just about what data types are there and how do we define literals and how do we assign the data type previously before assigning any values to it. And we studied that the only permissible values for Boolean is true and false. By default, all the decimal value is double. If you want to put it as float, you have to put f at the end. If you want to declare any integer as long, you have to put L at the back. Okay, and we saw a couple of things that why do we need long, why do we need int, and why do we need byte, and how the value crosses the ranges. Now the next thing that we are going to cover is called as typecasting. So let us go a bit into a theory about typecasting, and then I might today go only with the theory part, and then next day we'll look into the programming aspect of it. But let us study about typecasting. So what is typecasting? So the typecasting is the strategy of converting one primitive data type into another. Okay. I'll give you a very practical situation where we encounter something called as typecasting in daily life. Okay. Okay. So let us say that we all pay taxes, correct? We all pay taxes, correct? Isn't it? So let us say you bought something of rupees 100 and you pay a tax of, let us say, 12.5% on it, correct? So how much will you have to pay? So you will have to pay 112.5, correct? So if you see this 100 is an integer, isn't it? This is an integer. This 12.5 is a double, correct? And the entire result that you get here is also double, isn't it? So ultimately what you had to do is so at some point of your transactions, in some value, in some variable, let us say you have stored this value called as 100, and then you applied some mathematical operation, and the result that you get is also a double, correct? So if you see carefully, this integer after certain operation was converted into double, correct? So this could be one of the example. In calculations, we often find that we have to convert one thing from another. So this is where in practical scenario, if you write logics, you require typecasting, where it becomes very evident that you have to convert one data type into another. Okay, so this is called as basically typecasting. So what is typecasting? So typecasting is a process where developers assign a primitive data type value to other primitive type value. So I'll give you an example. Uh, what we can do is, for instance, assume every data type to be a bucket and value stored into it as a water. What we are going to do, we are going to put some analogy here. So this is my small bucket. This is my another bucket. This is my another bucket, correct? And this is my another bucket. So now let us imagine this, and there is something in it. It's something in it. There's something in it. Okay. So this small bucket is our byte. This is short. This is int, and this is long. Correct. So what we can do is, now just with your simple intuition, imagine, can we store the water from byte into short? Yes, we can. Can we store these two values, the value that lies in this range to this? Yes, we can do it. Can we put all these three things into this? Yes, we can do it. This is very evident. The similar concept is applicable for your data types. What you can do is, you can store the data types which are smaller than the current data type into it. What I mean to say is, you can easily store a value that is of byte, short, int into a long, right? If we draw, so we can say a subset sort of thing. So the outer one is a long, the inner one inside it is a short, and the one inside it is a no, sorry, this is an integer, this is short, and this is byte. Okay, so the one which is contained here, the outer one can contain the value of the inner. So this type of typecasting is called as implicit typecasting. You don't have to perform this implicit typecasting. Okay, this is automatically done by the compiler. So what happens is, when you try to store a data type of lower precision to one into upper precision, that is quite evident. This is called as implicit typecasting. Okay, so this is called as implicit typecasting, and this is also called as widening or upcasting. And basically, there is no loss of precision or information. I'll tell you why there is no loss of information. Just imagine that byte is what? This is 8 bits, this is 16 bits, this is 32 bits, and this is 64 bits. If you try to store any information that is stored in 32 bits, can easily be stored into something that is of 64 bit, isn't it? So actually there is no loss of precision, no loss of data, nothing. This is automatically done by the compiler. You don't have to explicitly do it. This is called as upcasting, okay, or widening. These are two very popular terms that you often encounter in your textbook. or rest of the things. Okay, so this is called as implicit typecasting, correct? So if you see this arrow wise diagram, so if you see it here, so in this double you can store all the previous value, in float you can store all the previous value, in long you can store all the previous value, and the rest of the things goes on. So I'll give you some of the example for this what we call at implicit typecasting. So I'll share some of the I'll just show you some of the examples. Okay, so it's example time. So let me just erase, or let me just comment out the things that I, okay. So don't worry about it. Just let me comment out this thing. Okay, and let me go down. So what I have to show you is this. Okay, so what I will write here is I'll write byte, my byte var is equal to 126. Correct. So what is this? This is my byte variable. Now I'll write here int as my int var is equal to my byte var. Okay, correct. And I'll try to print this my integer value. My integer val. And then I'll just print it out, my int var, and just observe the logs. See, without any exception or anything, I'm easily able to get this value. Why? Because we are trying to store this byte var whose range is what? This is 8 bits. What is this? This size is 8 bits, and we are trying to store some value that is stored in 8 bits into that is of 32 bits. So we can easily do this. Okay, so this is called as upcasting. Okay, so there is no issue with it. The same is true for rest of the thing. Like, let us say I write here double my double var is equal to 3.41 f. Correct. If you see this 3.41 f means what? This is a float variable, and we are trying to store this float variable into a double variable. So this code is going to compile without, I mean, with perfect ease. There will be no problem with it. So double var, and what I will put here is my double var. Okay, and I'll just simply run it. And now observe the logs. Now see that, correct. If you see at the last 3.41008530, it has took some garbage value with it. Why? Because double is, this is a double precision number, and float was precise up to 2 points. So it has got some garbage value at the end. If you see the number that you see here is had got more decimal points than we created here. Okay, because this float variable is upcasted to double. So there was no problem with it. Okay, same is true with one more example. I'll show you. I'll write char, let us say char var, char variable is equal to, I will put it a, and I'll try to take a like int, my int var, my int var1 is equal to char var, and I'll try to just print my int var1, and then this particular char var. So I'll print it. I'll show you the. So, oh, so no, I don't have to print char var. Actually, I have to print my int var1. Now see the logs. You'll see the ASCII value of a, that is 97. So if you remember the size of the a, that is character, is smaller than that of the integer. So your char can easily be get accommodated into int, correct? And we are getting the ASCII value of a, that is 97. So I guess you are very much clear with the upcasting thing, isn't it? Can I get a thumbs up for like you all guys understand upcasting? Then I will move to downcasting, the other part of it. or we'll continue tomorrow? Just can I get a thumbs up? Hmm. Okay, cool. So, so let us conclude this today because I have some other work. From tomorrow, I'll just tell you from tomorrow what we'll cover. From tomorrow, we are going to cover explicit typecasting and then some basic operators, and then we'll look into flow control. Okay. So, by meanwhile, goodbye. Have a great day ahead. Enjoy the Raksha Bandhan tomorrow, and some of you might have enjoyed today. And that's it from my part. Okay, if someone have to post something in the chat, anything that I should take care of, like I will open for 2 minutes and then I'll close it down. Like anything if you want to post, any criticism, any good thing, and anything you wish, like, or anything I should work upon or improve, anything of that sort. Mm. So I'm open to chat. I'm looking at the chat for the next 2 minutes. Um, mhm. I'll close it down at 9:02. So I'm open till then. Anything, any doubts in the previous class, today's class, anything, or what we are going to cover in the further sessions? Hmm. I'm still waiting. Anything? Okay, guys, then I am just turning it off. Thank you so much. Okay, then. Okay, we'll publish the assignments. Don't worry about it. Good night, good night, good night, everyone. We'll catch up tomorrow at this. We'll catch up tomorrow.